Mounting a SPOD disconnect on a chain-link fence presents a potential electrical safety hazard if not done correctly. The primary concern is the possibility of the fence becoming energized in the event of a fault within the disconnect. While metal buildings are often used to mount electrical equipment, the NEC, or National Electrical Code, has specific requirements for grounding and bonding to ensure safety. These requirements aim to create a low impedance path for fault current to return to the source, which will then cause the overcurrent protection device, such as the circuit breaker, to trip and to energize the circuit. The inspector's concern about the fence becoming energized is valid. If a fault occurs within the SPOD disconnect and the enclosure is not properly grounded and bonded, the fence could become a path for the fault current. This could expose anyone touching the fence to a potentially dangerous voltage. The NEC does not explicitly prohibit mounting a disconnect on a chain-link fence post, but it does provide guidelines that effectively address the situation. The relevant sections revolve around grounding and bonding. Firstly, NEC Section 250.4. A5 addresses bonding of electrically conductive materials and other equipment. This section requires that the exposed metal parts of electrical equipment be bonded together into the grounding electrode system. This includes metal enclosures such as the SPOD disconnect box. Secondly, NEC Section 250.96 covers bonding other enclosures. Metal fences are not specifically mentioned, but the principle applies. It states that metal enclosures and other metal non-current carrying conductive parts shall be bonded regardless of voltage. The key is to ensure that the metal fence post is properly bonded to the grounding electrode system. This can be achieved by running a grounding electrode conductor from the fence post to the grounding electrode. Thirdly, NEC Section 680.42 specifically addresses spas and hot tubs. This section requires that all metal parts within 5 feet of the inside wall of the spa or hot tub be bonded together. This includes metal fences. The bonding conductor must be sized according to NEC Table 250.122. Based on the size of the circuit supplying the SPOD disconnect. The purpose of this bonding is to create an equipotential plane around the spa, minimizing the risk of electric shock. The NEC also requires that the grounding electrode system be properly installed. This typically involves grounding electrodes such as ground rods, ground rings, or metal water pipes. The grounding electrode conductor must be sized according to NEC Table 250.66. Additionally, using metal strut to mount the disconnect to the fence post could create a reliable electrical connection. This can aid in the bonding process, but it's not a substitute for a dedicated bonding conductor. Ensure the strut is also properly bonded. The inspector's concern likely stems from the potential for improper grounding and bonding. If the fence post is not adequately bonded, it could become energized during a fault, posing a safety hazard. To address the inspector's concerns, you can propose a solution that incorporates proper grounding and bonding techniques. This would involve, firstly, installing a grounding electrode conductor from the fence post to the grounding electrode system. The size of the conductor should be in accordance with NEC Table 250.66. Secondly, bonding the SPA disconnect enclosure to the fence post using a bonding jumper. This ensures that the enclosure and the fence post are at the same electrical potential. Thirdly, ensuring that all metal parts within 5 feet of the spa or hot tub are bonded together as required by NEC Section 680.42. Fourthly, providing documentation to the inspector showing that the grounding and bonding system meets the requirements of the NEC. This may involve providing calculations and diagrams. If you can demonstrate that the installation will be safe and in compliance with the NEC, the building department may be more likely to approve the installation. However, it's important to note that the final decision rests with the inspector. They have the authority to interpret the code and make decisions based on the specific circumstances of the installation. Consider these points regarding grounding and bonding requirements. Firstly, all metal enclosures containing electrical conductors must be grounded according to NEC Section 250.8. This grounding ensures a low impedance path for fault currents, allowing overcurrent protection devices to operate and clear the fault. Secondly, bonding involves connecting all non-current carrying metal parts to create an electrically conductive path. This equipotential plane minimizes voltage differences and reduces the risk of electric shock. Thirdly, the grounding electrode system, described in NEC sections 250.50 through 250.70, provides a connection to the earth. Common grounding electrodes include ground rods, metal water pipes, and concrete encased electrodes. Fourthly, the size of grounding and bonding conductors is determined by NEC tables 250.66 and 250.122, respectively, based on the size of the circuit's overcurrent protection device. Fifthly, proper connections are crucial. Use approved connectors and methods to ensure reliable electrical connections for grounding and bonding conductors. Sixthly, grounding and bonding are especially critical in wet locations, such as spot areas, where the risk of electric shock is higher. Follow NEC Article 680 for specific requirements in these areas. Seventhly, metal strut, if used to mount the disconnect, must also be bonded to the grounding system to ensure it doesn't become a potential shock hazard. Eighthly, inspectors may have specific interpretations or local amendments to the NEC. Always consult with the local building department for clarification. Ninthly, documentation of the grounding and bonding system, including conductor sizes, connection methods, and grounding electrode details, is essential for demonstrating compliance. Tenthly, improper grounding and bonding can have serious consequences, including electric shock, equipment damage, and fire hazards. Always prioritize safety and follow the NEC guidelines. 11thly, remember that electrical codes are constantly evolving. Stay updated on the latest versions of the NEC and any local amendments. 12thly, if you're unsure about any aspect of grounding and bonding, consult with a qualified electrician. They can provide expert advice and ensure that the installation is safe and compliant. Also, consider these safety aspects related to your SPA disconnect installation. Firstly, ensure the disconnect is readily accessible as required by NEC section 680.40. This allows for quick de-energization of the SPA in case of an emergency. Secondly, use a weatherproof enclosure suitable for outdoor use. The enclosure must protect the disconnect from rain, snow, and other environmental factors. Thirdly, properly label the disconnect with clear signage indicating its purpose. This helps prevent confusion and ensures that the correct disconnect is used. Fourthly, install a ground fault circuit interrupter, or GFCI, for the SPA circuit. A GFCI protects against electric shock by detecting small ground faults and quickly de-energizing the circuit. Fifthly, periodically inspect the disconnect and the surrounding area for any signs of damage or corrosion. Address any issues promptly to prevent potential hazards. Sixthly, never attempt to work on electrical equipment unless you are qualified and authorized to do so. Electrical work can be dangerous, and it's best left to the professionals. Seventhly, before working on the SPA disconnect, always turn off the power at the main breaker panel. This ensures that the circuit is de-energized and safe to work on. Eighthly, use insulated tools when working on electrical equipment. Insulated tools help protect against electric shock. Ninthly, wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves, when working on electrical equipment. Tenthly, be aware of your surroundings and avoid distractions when working on electrical equipment. 11thly, follow all applicable safety regulations and guidelines. 12thly, if you have any doubts about the safety of the installation, consult with a qualified electrician. To summarize, while the NEC doesn't explicitly forbid mounting a SPA disconnect on a chain link fence, it emphasizes proper grounding and bonding to prevent electrical hazards. Consult with your local building department and a qualified electrician to ensure a safe and compliant installation. By following these guidelines, you can address the inspector's concerns and create a safe electrical environment for your SPA. It is essential to have an open discussion with the inspector and provide detailed information about your proposed grounding and bonding plan. The more information you provide, the better equipped the inspector will be to make an informed decision. Remember that the inspector's primary concern is safety, and demonstrating a commitment to safety can go a long way in gaining their approval. Additionally, having a licensed electrician involved in the project can add credibility to your proposal. Electricians are familiar with the NEC and can provide assurance that the installation will meet the required standards. Ultimately, the goal is to find a solution that is both aesthetically pleasing and electrically safe. By working with the inspector and a qualified electrician, you can achieve this goal and ensure that your spa disconnect is installed in a manner that meets all applicable codes and regulations. In addition to grounding and bonding, consider the location of the disconnect relative to the spa. The NEC requires that the disconnect be located within sight of the spa and at least 5 feet away from the inside wall of the spa. This ensures that the disconnect is easily accessible and that users are not exposed to electrical hazards while in the spa. Also, think about the potential for physical damage to the disconnect. If the fence is located in an area where it could be struck by vehicles or other objects, consider installing a barrier to protect the disconnect. Furthermore, ensure that the disconnect is properly supported. The fence post may not be strong enough to support the weight of the disconnect, especially if the disconnect is large or heavy. In this case, you may need to install additional supports.